All right, let's talk about something we've all experienced. That sudden, jarring thump of hitting a pothole. And you always wonder, why can't we just get ahead of these things? Well, it turns out the answer isn't just about throwing more asphalt at the problem. It's about using smarter data. So in this explainer, we're going to break down how generative AI is literally changing the game for road maintenance, moving us from a world of fixing what's already broken to preventing the break from ever happening.
You know, this quote right here gets to the absolute heart of the issue. A pothole isn't the start of the problem, it's the very end. It's just the symptom you can finally see. The real failure started deep inside the pavement structure, probably months, maybe even years before. So by the time that hole shows up, the damage is already severe, and the cost to fix it properly has just skyrocketed. We've been playing a game of catch-up, and it is an incredibly expensive one.
So the real hidden cost of that pothole, it's all about timing. The way we've traditionally taken care of our roads has been fundamentally reactive. We wait for someone to complain or for an inspector to spot something obvious. And as we're about to see, that is by far the most expensive way to do things.
Yeah, in the industry, this is what we call reactive maintenance. And the logic is pretty simple, right? Something breaks, we go fix it, a pothole appears, a crew gets sent out. But this whole approach can be 5, even 10 times more expensive than getting in there early. It's just a wildly inefficient way to manage a huge asset like a road network. Think about it. It's like waiting for the check engine light to come on after the engine is already seized up.
So what if we could change all that? This is where we get to the predictive mindset. It really requires a huge shift in how we think about our roads. We have to stop seeing them as these static, lifeless slabs of asphalt and start treating them for what they really are: dynamic, constantly degrading systems that are getting worn down every single day by traffic, weather, and just time. And this slide really lays out the difference perfectly. On the left, you've got the old way. It's reactive, it's based on a fixed schedule, maybe once a year, and the priorities are often just set by whoever is screaming the loudest. But on the right, you have the predictive model. It's proactive. The schedule isn't fixed, it's constantly changing based on real data. And the priorities? They're set by optimization algorithms to get the best bang for your buck. We're moving from a calendar to a condition report. And that simple shift reframes the entire goal. See, the objective isn't just to have a road with no potholes. That's a tactic, not a strategy. The real prize, the strategic win, is getting the absolute maximum life and performance out of our infrastructure for every single dollar we invest. It's about maximizing the value of the asset, not just endlessly patching holes.
Okay, so the philosophy makes sense, but how does this actually work? What's under the hood, technically? Let's get into the anatomy of the system. We're going to walk through the whole data pipeline, right from the asphalt on the street all the way to a work order getting sent to a repair crew.
This whole flow is basically the digital nervous system for the entire road network. So first up, data capture. Picture vehicles with high-res cameras and LiDAR constantly scanning the road, just gathering terabytes of raw data. Then, all that data gets fed into distress detection. This is where computer vision models look for the tiniest, earliest signs of wear, cracks, and roughness a person would totally miss. All that info then gets organized in a feature store, creating this detailed, living health record for every single meter of road. From there, degradation models use that history to predict the future, calculating the remaining useful life. And finally, the decision engine puts it all together to create the smartest, most optimized work plan possible.
Now, out of all those steps, that last one, the decision engine, that's the most revolutionary part. This is where generative AI comes in. And we're not just talking about number crunching here. This is about sophisticated, high-level reasoning. This is the brain of the whole operation. Which, of course, brings up the obvious question, right? Where exactly is the Gen AI in all of this? Is it the thing that's actually spotting the cracks in the road? And the answer is really specific and super important. It's not in a detection. It's in the decision. We use other kinds of AI, like computer vision, for finding the physical problems. The unique superpower of GenAI here is applied to a much higher-level job, reasoning through incredibly complex trade-offs, planning ahead, and optimizing an entire maintenance program for a whole city. Let's look at a real example of how this plays out. On the left, we've got a structured prompt. See how we give the AI a role? You are a road asset planning agent. Then we feed it the critical data: pavement health, traffic info, budget limits, and the degradation models. And on the right, look at that output. It's not just a paragraph of text, it's structured, machine-readable data. It recommends a precise action, a specific time window, how many years of life this will add, and even calculates the cost savings. This is actionable intelligence at a massive scale. Okay, this is all fascinating tech, for sure. But in the real world, none of it matters unless there's a clear return on investment. So let's talk about proving the bottom line. How does this actually save money?
And here's the number that gets everyone's attention, 38%. In the example we just saw, the system figured out a 38% cost saving by jumping in early with a preventative fix, instead of waiting for a total failure later. When you're managing city or state budgets in the millions or even billions, well, that's a huge number.
But what does that 38% actually mean on the ground? Well, the return on investment pops up in a bunch of places. It means you can put off spending massive capital on full road reconstructions for years. It means the overall life cycle cost of the whole network goes down. You have way fewer disruptive, expensive emergency repairs. And what about for us? It means thousands of lane days saved. That's less time stuck in traffic. It even means a smaller carbon footprint from doing fewer giant construction projects.
So if there's one thing you take away from all this, let it be this right here. GenAI doesn't pour asphalt. It doesn't patch potholes. It fixes the single most critical and expensive part of managing our infrastructure, the timing. By figuring out exactly when and where to step in, we can get longer-lasting roads for way less money, all before you even see a problem. So the question is no longer just how to fix our roads, but when. And now, for the first time, we have a system that can actually give us the answer.